Hello everyone, welcome to our AP Physics Impulse and Momentum video. My name is Pablo.
My name is Julius.
And I'm Nico.
The objective of today's lab is to be able to plan data collection strategies to test the law of conservation of momentum in a two-object collision that is elastic or inelastic and analyze the resulting data graphically.
Okay, so the materials we will need are two carts, a track, two end stops, two photo gate supports, two cart picket fences, two photo gates, sensors, one Lab Pro,
Logger Pro interface.
Logger Pro
Logger Pro interface, and one computer.
And now we'll be showing you guys how to set everything up. First, we're going to put the end stop on either side of the track. Next up, we're going to be adding the photo gate supports connected to the photo gate sensor. Okay, and my friend Nico will do the same thing on the other side.
Bruh, look at this dude.
Add it on there.
Yeah.
And now we'll plug in the photo gate sensors to our Lab Pro interface. Logger Pro interface. Now we will connect it
To the Logger Pro.
to our computer. To our computer, which has Logger Pro on it,
Oh!
as you can see right here. Next up, we'll put the carts on the track with the picket fences. And now we're done.
Bruh, look at this dude.
We will be calculating the momentum of the two objects before and after a collision.
So before, the momentum, like when this cart is in motion and this one's at 0, so we already know that this cart's momentum is 0. So we're pretty much calculating the momentum of this cart, and then like before, and then after they collide and their momentum of the two carts combines.
The equation that we'll be using for this lab is since in this case the second mass has no velocity, so v naught 2 is 0, would only the momentum would only be of this cart, which is m1 v naught 1, should be equal to the final velocity times the total mass of the combined. So this is how we're gonna set up the experiment. As you can see, the second cart begins at rest. The first one is gonna be pushed and they stick together.
So I have already created the calculated columns, but if you wanted to make one, you could go to data and press new calculated columns. So for the initial momentum, it would usually you would have the momentum of both carts, but since one cart is at 0, you'd only have the mass of the cart times the velocity. So the mass of the cart that's moving is 0.521 kilos. So that's your first calculated column, and then for your final momentum, since they stick together, you add both masses, which would then be 1.042 kilos, and you multiply that by the velocity. So this right here is what your graph would look like, and then this right here is what your chart of data would look like.
Due to the law of conservation of momentum, the momentum before the collision should be the same as the momentum after the collision. Okay. This is what the graph would look like with perfect data.
So now we will run the experiment.
Since the momentum of mass 1 is over here and the total momentum at the end with the final velocity is right here, you see that they're basically equal because momentum is conserved, and there's a little bit of difference because of course there's a little bit of friction on the track and there's no frictionless track.
There's also a small space here, and that is simply because there's a point where nothing is being measured between the two photo gates, so that's why there's like a blank space.
There's no data being collected.
So pretty much what we should focus on in the graph is this part right here. since after that, it's just picking up random things.
Even if you add more mass, the momentum will always be conserved.
Mass times velocity. Before the collision, there would be more of a velocity, but there's less of a mass. But then after the collision, and they're together, mass is increased, but velocity is decreased. Therefore, momentum is conserved.
So since we're using the equation that the mass times velocity of this cart is equal to the mass times velocity of these two carts combined, we can assume that since the mass is doubling because the two carts become one combined, that the velocity of this is going to be half of the velocity of this when it starts.
So our question was, what information would you need to collect in order to test the law of conservation of momentum? And the information you would need to collect would be the mass of both objects, the initial velocity of both objects, and the final velocity of both objects. And then with this information, you can create equations to find the momentum before and after the collision so that you're able to test the law of conservation of momentum. So to conclude our video, in this video we explained that how to test the law of conservation of momentum by collecting the mass of objects and the velocity of objects before and after a collision. In this case, since the objects stuck together, the masses got increased and the velocity decreased, so therefore the law of conservation of momentum was fulfilled because the momentum was the same.
Bruh. Look at this dude.